According to the 2020 National Electrical Code, Section 334.30, non-metallic sheathed cable shall be permitted to be secured by stapling. However, it's important to understand the scope and limitations of this permission, particularly in specific installation contexts. The code itself doesn't explicitly define height restrictions for securing cables. Therefore, on the surface, the electrician's citation might seem technically correct. However, the application of electrical codes often requires sound judgment and consideration of best practices that go beyond the minimum letter of the code. The question arises, is stapling the best practice in a low-lying basement environment? In situations where the clearance is less than 7 feet, drilling through the rafters is generally the more recommended approach for securing electrical cables, even though stapling may be permissible under Section 334.30. There are several reasons that underpin this recommendation. Firstly, physical protection. Cables installed in low clearance areas are inherently more susceptible to accidental contact. In the event of someone bumping into or pulling on a stapled cable, the staples can exert pressure on the cable's outer jacket, potentially damaging the insulation. The repeated action of such events could lead to compromised wiring, creating safety hazards such as short circuits, ground faults, or even electrical shock. Drilling a hole through the rafter and running the cable through it provides a more robust form of protection. The wood itself acts as a barrier, shielding the cable from direct impact. Secondly, long-term integrity. Over time, staples can loosen or corrode, especially in damp basement environments. This can lead to the cable sagging or becoming detached, increasing the risk of damage or accidental contact. Drilling through the rafters offers a more secure and permanent installation method. The cable is supported along its length by the wood, reducing the strain on any single point of attachment. Thirdly, best practice versus minimum requirement. The NEC represents a minimum standard for electrical safety. While compliance with the code is essential, it's not always sufficient to ensure optimal safety and reliability. Experienced electricians often adopt practices that exceed the minimum requirements of the code, taking into account the specific conditions of the installation. In this case, while Section 334.30 permits stapling, drilling through the rafters reflects a more proactive and safety-conscious approach, given the low clearance environment. To further elaborate on non-metallic sheathed cable installation, there are a number of critical factors to consider. Firstly, cable support. Non-metallic sheathed cable must be supported and secured in a manner that protects it from physical damage. The NEC specifies the maximum intervals at which the cable must be supported, typically every 4.5 feet and within 12 inches of boxes, cabinets, or fittings. Whether stapling or drilling is employed, these support requirements must be met. Secondly, bend radius. When installing non-metallic sheathed cable, it's essential to maintain the proper bend radius to avoid damaging the conductors inside. The NEC specifies that the bending radius of the cable should not be less than 5 times the diameter of the cable. Sharp bends can stress the insulation and lead to premature failure. Thirdly, protection from nails and screws. When running cables through wood framing, it's crucial to protect them from being penetrated by nails or screws. This can be achieved by installing metal nail plates over the cable where it passes through the framing, particularly in areas where there's a risk of screws or nails being driven into the cable during future construction or renovation work. Fourthly, proper stapling technique. If stapling is used, it's important to use the correct type of staples and to install them properly. The staple should be designed for use with non-metallic sheathed cable and should be driven in straight and flush with the surface of the wood, without compressing or damaging the cable. Fifthly, avoiding over-tightening. When securing cables, it's crucial to avoid over-tightening the staples or straps. Over-tightening can damage the cable insulation and create a point of stress that could lead to failure over time. Sixthly, protection from physical damage. In areas where cables are exposed to physical damage, such as in unfinished basements or garages, they should be protected by conduit or other approved means. This will help to prevent damage from impacts, abrasion, or other hazards. Seventhly, compliance with local amendments. It's essential to be aware of any local amendments to the NEC that may affect the installation of non-metallic sheathed cable. Some jurisdictions may have stricter requirements than the national code, so it's important to check with the local authorities to ensure compliance. Eighthly, inspection and testing. After the installation is complete, it's important to inspect and test the wiring to ensure that it's safe and functioning properly. This includes checking for proper grounding, polarity, and insulation resistance. Ninthly, professional installation. Electrical work should always be performed by a qualified and licensed electrician. Electricians have the training, experience, and knowledge necessary to install wiring safely and in accordance with the code. Improperly installed wiring can be a fire hazard and could lead to serious injury or death. Tenthly, ongoing maintenance. Electrical systems should be inspected and maintained on a regular basis to ensure that they are in good working order. This includes checking for loose connections, damaged wiring, and other potential problems. By following these guidelines and best practices, you can help to ensure the safe and reliable installation of non-metallic sheathed cable in residential and commercial buildings. Now let's consider additional factors related to electrical safety in low-lying basements. One important concern is moisture. Basements are often prone to dampness or even flooding, which can create hazardous conditions for electrical wiring. Water is a good conductor of electricity, so any contact between water and exposed wiring can create a shock hazard. Therefore, it's essential to take precautions to protect electrical wiring from moisture in basements. Firstly, use of ground fault circuit interrupters. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock by detecting ground faults and immediately shutting off the power to the circuit. GFCIs are required in all wet locations, including basements, to protect against shock hazards. Secondly, waterproof enclosures. Electrical outlets, switches, and other devices in basements should be installed in waterproof enclosures to protect them from moisture. These enclosures are designed to prevent water from entering the device and creating a short circuit or shock hazard. Thirdly, elevated wiring. Electrical wiring in basements should be run as high as possible to minimize the risk of contact with water. This can be achieved by running the wiring along the ceiling or high on the walls, rather than along the floor. Fourthly, sump pumps. If the basement is prone to flooding, a sump pump should be installed to remove any water that accumulates. The sump pump should be connected to a GFCI protected circuit to protect against shock hazards. Fifthly, proper ventilation. Proper ventilation can help to reduce moisture buildup in basements. This can be achieved by installing windows or vents that allow fresh air to circulate. Sixthly, regular inspections. Basements should be inspected regularly for signs of moisture or water damage. Any leaks or water intrusion should be repaired promptly to prevent electrical hazards. Seventhly, professional assessment. If there are concerns about moisture or electrical safety in the basement, a qualified electrician should be consulted to assess the situation and recommend appropriate solutions. Another important consideration is the presence of hazardous materials. Basements are sometimes used for storage, and they may contain hazardous materials such as flammable liquids, pesticides, or cleaning chemicals. These materials can pose a fire hazard or health risk if they come into contact with electrical wiring. Firstly, proper storage. Hazardous materials should be stored in tightly sealed containers and kept away from electrical wiring. They should also be stored in a well-ventilated area to prevent the buildup of fumes. Secondly, spark-proof equipment. If flammable liquids are stored in the basement, spark-proof electrical equipment should be used to prevent ignition. This includes spark-proof outlets, switches, and lighting fixtures. Thirdly, ventilation. Proper ventilation is essential to prevent the buildup of flammable fumes. The basement should be well ventilated to allow fumes to dissipate. Fourthly, regular inspections. Basements should be inspected regularly for signs of leaks or spills of hazardous materials. Any spills should be cleaned up immediately and disposed of properly. Fifthly, professional assessment. If there are concerns about hazardous materials in the basement, a qualified environmental professional should be consulted to assess the situation and recommend appropriate solutions. In summary, while NEC 334.30 technically permits stapling of non-metallic sheath cable, drilling through rafters is often a safer and more robust practice in low-lying basements. This approach offers better protection against physical damage, ensures long-term integrity, and aligns with best practices for electrical safety. Always prioritize safety and consider the specific conditions of the installation when making decisions about electrical wiring methods. Furthermore, basements often have moisture concerns. Proper ventilation and the use of GFCI devices are critical to safety.